So in this last section about quadratic functions, we're looking at quadratic equations that have complex solutions. Now the discriminant will help us see what types of roots that quadratic has. So we do see if there are two real x-intercepts, maybe there's only one real x-intercept, but there's also the option that there are zero real x-intercepts. And if there are zero real x-intercepts, it happens when our quadratic function will never cross the x-axis. But that doesn't mean there are not complex solutions to when that function equals 0. So if I look at these four equations, we're going to find the solutions algebraically. So for number 9a, we have 2x squared plus 80 equals 0. We would first subtract the 80 and get negative 80 on the right side, and then divide by 2 to get x squared equals negative 40. When we take the square root of both sides, we have positive or negative square root of negative 40. Automatically, that tells me I'm dealing with a complex number. So we simplify the radical. I know there's going to be an I because of the square root of a negative, but we also need to simplify the square root of 40. Now, however you simplify your radical, whatever method makes sense to you, you can use. It does simplify down to 2 square roots of 10. So that would make that 2i square roots of 10 because it was the square root of a negative. We have two solutions. It's positive and negative 2i square roots of 10. So there are two complex solutions to that equation. For b, x squared plus 49 equals 0, we would do the same thing and subtract 49 from both sides to get x squared equals negative 49. When we take the square root of both sides, we have plus or minus the square root of negative 49. But that one will come out nice because the square root of 49 is a perfect square. So if I square root 49, we get 7. Because it's the square root of a negative, it's 7i. So we have two complex solutions, 7 plus 7i, or positive 7i, and negative 7i. For c, we need to get the equation equal to 0. So we have x squared plus x equals negative 2. If I add 2 to both sides, we have x squared plus x plus 2 equals 0. And we find a function that will not factor. Since it will not factor, we're going to need to do the quadratic formula. So we have x equals negative b, in this case b is 1, plus or minus the square root of b squared, 1 squared in this case, minus 4ac, so minus 4 times 1 times 2. And the entire thing is being divided by 2a, so 2 times 1. That simplifies down to negative 1 plus or minus the square root of some value divided by 2. So now I'm just trying to figure out what is going underneath that radical. Now you can do this in your calculator as well if you want, or you can do it by hand. But you have 1 squared minus 4 times 1 times 2 and get negative 7. Because we're taking the square root of a negative, we're going to need to simplify that with an imaginary number. So negative 1 plus or minus I square roots of 7 divided by 2. The square root of 7 can't simplify further, so we just leave it that way. All right, and then d. Now d looks pretty complicated. It's got several fractions, so maybe we want to clear out the fractions. All right, so if I look at every single fraction, a common denominator would be 12. So if I multiplied everything by 12, I can clear out the fractions. So I'm going to do 12 times 5/12 x squared equals 12 times 1/2 x minus 12 times 1/4. Everything is being multiplied by 12. That will leave me with 5x squared equals 6x minus 3. That's a much nicer equation to work with than the previous one with all the fractions. Now I could do the quadratic formula with all of these fractions. That's possible, but it's prettier, or at least easier in my opinion, to do it with these integer values. I do need to get it equal to 0, so we have 5x squared minus 6x plus 3 equals 0. Then if I do the quadratic formula, we have x equals negative b, so negative 6, plus or minus the square root of b squared, so negative 6 squared, minus 4 times 5 times 3, all over 2a, so all over 2 times 5. And we're going to simplify that out. We get positive 6 plus or minus the square root of some value divided by 10. And let's figure out what's going on inside that radical. So we have parentheses, negative 6 squared minus 4 times 5 times 3, and we get negative 24. That automatically tells me I'm dealing with some complex solutions, and we would simplify our radical. I'm going to extend this down to the next sheet of paper, but we have x equals 6 plus or minus 2i square roots of 6 divided by 10. So we're just simplifying that square root of negative 24. We're just practicing that simplifying radicals skill that we learned in the previous unit. And now I'm simplifying the whole fraction. So if I look at each term and think what is a common factor, it would be 2. So I can divide every term by 2 and get 3 plus or minus I square roots of 6 divided by 5. So if you have a quadratic equation, you should have 2 solutions no matter what. Those 2 solutions might end up being complex, but they don't have to be. They can be real numbers as well. We see that often. But when they are complex, it's because we're dealing with a quadratic function that doesn't cross the x-axis. All right, so hopefully that helps clarify some of these complex solutions.